sklearnutilsmurmurhash332. Description: this function is a fast and efficient hash function used to generate a 32-bit hash value for a given input. Murmurhash3 is a non-cryptographic hash function known for its speed and distribution quality. Inputs. Key: the input data to be hashed can be any hashable Python object like string, tuple, list. Seed: an integer value used as an initial seed for the hash function. It helps to improve the randomness of the hash values. Outputs. Hash value: a 32-bit integer representing the hash value of the input key. Steps. The function iterates through the input key, processing each byte to generate a hash value. It uses a series of bitwise operations, rotations, and multiplications to create a unique hash value. The seed value is used as the initial state for the hash function, ensuring a unique hash output for different seeds. Metrics. Collision rate: it measures how often different inputs produce the same hash value. A low collision rate is desirable. Distribution: it measures how evenly the hash values are distributed across the output range 0 to 232 to 1. An even distribution indicates better hash function performance. Visualization plots. Histogram of hash values: this plot shows the frequency distribution of the hash values generated for a set of inputs. Collision probability plot: this plot shows the probability of collisions for different numbers of inputs. Fine-tune parameters. Seed: the seed value can be adjusted to change the initial state of the hash function, influencing the hash values. Uncertainty methods. None, as it is a deterministic function. There is no inherent uncertainty in the output. Challenges and fixes. Challenge 1: collisions: it is possible for different inputs to generate the same hash value, though the probability is relatively low. Sample use case that resulted in challenge 1: two different strings, hello and world, might produce the same hash value. Fixes to challenge 1: use a stronger hash function like SHA-256 if a lower collision probability is needed for cryptographic purposes. However, this would be slower. Challenge 2: limited output range: the output range is limited to 32 bits. Which might not be sufficient for larger datasets with a high probability of collisions. Sample use case that resulted in challenge 2: when hashing a large number of distinct inputs, the chances of collisions increase due to the limited output range. Fixes to challenge 2: use a larger hash function like murmurhash3128 or a cryptographic hash like SHA-256.